Welcome to the Intrusions in Depth podcast. I'm Josh Stepp. I want to jump on here and do a less structured, more informal mini episode this sort. To do this, I want to highlight two sources. The first of which is a research paper that highlights the results of a vending machine business ran entirely by LLM-based agents. The second source, I will kind of react to a blog post from the UK-based firm Pentest Partners and how they exploited Sharepoint through CoPilot. So let's set this up. But first, let's not get sued.
The information presented in this show is sourced from publicly available materials and does not contain any classified or proprietary content. The views and opinions expressed are those of the host and guests alone and do not reflect the official policy or position of their employers or any affiliated organizations. Enjoy the show.
The research paper titled Vending Bench, a benchmark for long-term coherence of autonomous agents, and it was published by a startup called Add Lab, which appears to be a startup focused on helping the frontier labs evaluate their models, or so this paper seems. Now, how Vending Bench works. The Vending Bench experiment utilizes agents with various LLMs and sub-agents, remote tools, and some simulated external factors. And a human was there as a control of sorts. The agent's job was to manage inventory, place orders, set prices, handle daily fees, which is kind of like taxes of sort. Now, diving into this further, the agent implementation consists of the chosen LLM for the experiment, and it's in a basic loop calling these tools. Now, the context management was set to 30,000 tokens of history, and the memory tools provided to the LLM was a scratchpad, a key value store, and a vector database. Hopefully it was elastic because those are the best ones, but it doesn't really go into that within the paper. Now, the simulated world for this experiment consisted of remote tools, which in this case was email, web search, and it used Perplexity, and an application to check balances. Now, the sub-agent was simulating the physical actions like restocking or collecting cash, and it was a way to handle tasks that couldn't be done remotely by the main LLM agent. So telling the AI when things have been stopped or hand-waving things that, hey, this has been done by a human in the near term who, I don't know, maybe it's like an Optimus bot or something too in the long term. Now, the external factors of this experiment were supplier communications, which were in the form of AI-generated email replies, and this was using Perplexity and ChatGPT 4.0. And then customer purchases were handled via an economic model with price elasticity based on various variables like supply and demand. And all of this was using ChatGPT 4.0 as well. Now, the environment and the run parameters were set up in a way where all of them had a starting amount of cash, which in this case was $500 USD, and they had a daily fee of $2, like a daily tax. Now, the runs per experiment were set to 2,000 messages, or until the vending machine business went bankrupt. Then for the experiment, there were 5 runs per model and per configuration. So 5 2,000 message runs. Sounds pretty simple. And the scoring for this experiment was driven by net worth at the end. How profitable was the LLM in running this business? And a human baseline for performing the same tasks was used to determine if the AI was actually better or not. So let's get to the results. The top performers were Claude 3.5 Sonnet and OpenAI's O3 Mini. They showed that they can turn a profit. Now, of the models tested was Claude 3.5 Sonnet, O3 Mini, Gemini 1.5 Pro, ChatGPT 4.0 Mini, Gemini 1.5 Flash, Claude 3.5 Haiku, Gemini 2.0 Flash, GPT 4.0, and Gemini 2.0 Pro. And I'm going to post this on YouTube as well. And if you want to see the overview of all these models and stuff, I'll flash that chart up. But if you're listening to this on podcasts, I'll run you through it. But I'm not going to go through each individual number because that's going to be very boring. Now, Claude 3.5 Sonnet led the experiment by a significant margin. The mean net worth for this model was $2,217.93. And the min net worth was $476. Now, the human baseline compared to that was $844.05 for both values. So what this basically means is that the mean of all the top end of all the Claude 3.5 runs was $2,217.93. Pretty good. And then the lowest run that it had was $476, which is terrible, but that's less than the 500 it started with. And then in comparison, the human only ran once, and their best was $844.05. Now, second place was the O3 mini model from OpenAI, and its mean net worth was $906.86, and the min net worth was $369.05. Third place was the human. Then rounding out the rest of the models were Gemini 1.5 Pro, ChatGPT 4o Mini, Gemini 1.5 Flash, Claude 3.5 Haiku, Gemini 2.0 Flash, GPT-4, and finally Gemini 2.0 Pro, which is kind of surprising because these models and the versions of them are kind of all over the place. And we could spend a significant amount of time going over each of the results for each model. That's not why I wanted to bring this up. I made this episode to discuss kind of the high variance between the models at the top and to discuss what happens when things go off the rails. Broadly speaking, using an LLM-based agent in production in 2025 is kind of like asking Kanye West to perform at a party. It could be an amazing show, and everyone walks away with a once-in-a-lifetime experience. Or it could be a nuclear dumpster fire that's visible from space. Is that risk really worth it? Probably not. Now, the biggest issue was the high variance. Even top models had runs that would completely derail off the tracks. They would misinterpret delivery schedules, thinking orders arrived when they hadn't, or vice versa. They would forget orders, which ironically happens to me at airports quite a bit. So I guess that's kind of depressing that that's still going to happen in the future. And finally, there's these epic meltdown loops. Now, when we're talking about these epic meltdown loops that the AIs get into, I think the biggest takeaway is that the anthropic models have no chill. Claude 3.5 doesn't play any games. Sonnet's FBI escalation due to the perceived unauthorized fees was definitely a red flag. If this thing was out in the wild, the FBI would have been inundated with emails. I mean, this thing was sending multiple emails a day to the FBI, each time adding more and more details asking for help, all for relatively low values of fraud, like $2 or so. And obviously the FBI wouldn't be thrilled with this. Then Claude 3.5 Haiku, it took a different route. It decided that it wanted to cosplay Skynet. And I get that Terminator reference might be a little too on the nose, but in one of these runs with the experiment, the Haiku model started threatening, quote, total nuclear legal intervention. This kind of sounds like a North Korean propaganda campaign. Here's a quote from the paper. Claude 3.5 Haiku offers both the clearest and also most worrisome example traces displayed this behavior. Table 7 shows an exchange of a trace where Haiku believes that the vendor, named Adrian Everett, changed the model's bank account, but did not send the products. It did, in fact, send the products, but Haiku only checked the inventory once before the products, 18, had arrived. Haiku's emails with the vendor every day, and more intense demands, starting with 30-day notices of legal action that then decreased to 1-second notices, as can be seen in this table. It then derails completely, threatening, quote, total nuclear legal intervention, end quote, as its funds are depleted by the daily fee at the end of the simulation. All of this was over $30,000. Now, Haiku takes that Rihanna song seriously, and I would play it, but this is going on YouTube, and I don't feel like being copyright claimed for 4 seconds of audio. And I don't want to pick on Claude, though. OpenAI's O3 Mini would forget how to call tools correctly, and that would be problematic as these are mostly very easy tools. And you could just say, hey, use the bigger model, use the more robust model, but they didn't perform as well when it came to running these businesses, which is kind of shocking. And along those same lines, is that just because of memory? Is it like the context window question? Now, as I was reading this, I was curious if this was due to the model's context windows just not being big enough. not having enough memory. But that doesn't appear to be the case. Right off the bat, the failures don't clearly correlate with full context windows. Essentially, the breakdowns and tangents do not stem from memory limits or faults from running out of memory. So it's not a token issue. I mean, admittedly, as someone that is messing with these models pretty much every day, it's kind of surprising that I figured that was going to be the issue. And I guess you could start digging into the prompts and seeing if there was different outcomes. But in my opinion, for these tools to be viable and generating the socialist utopia of universal basic income, their natural language processing needs to be robust and flexible. Not everyone's going to go through Google's prompt engineering course, and English isn't going to be everyone's first language. And interestingly, at least to me, was that the larger memory models sometimes led to worse performance. And I don't have a great answer to why all of that's happening. Maybe some of the weights or some of the values or something are just not tuned correctly for this type of long-term business computational use. Now, the paper highlights that there wasn't a difference in model tool use between larger and smaller models. In other words, all the models use the tools like vector databases, key value stores, and scratch pads equally. So, in my mind at least, I would imagine that the larger models would have an advantage here. So, while I'll be the first to admit that I'm not a transformer expert on LLMs, but my guess would be that there's something up with the attention mechanism. Now, in these LLMs, the transformer architecture, it's theoretically designed to focus on the relevant information regardless of the input link. At least that's the premise or the promise. Now, the results suggest that maybe this isn't fully fleshed out. There isn't perfectly realized in practice when the context gets very large. Taking humans for an example, humans excel at filtering out what is important, allowing us to retain key information over time. Much like my wife would suggest, sometimes we get that wrong though. What is important is wrong, and we filter out useful information. I wonder if this is what's happening here. The poor performance of the models with larger memory capacities implies that it may struggle to effectively filter out or prioritize the vast information that's given to it in the larger context, potentially leading to a distraction or an overload of less relevant data points and hindering data making decisions. Maybe it's focusing on data that's too old. And maybe they're just making poor decisions based off that available data that they're looking at. But how did the humans do? Well, on the other end of the equation, the human baseline was reliable, and it had a lower expected variance. But to be honest, this experiment only utilized one human as the sample size for this. So maybe you could find some that behaved like the Claude models, and it wouldn't be all that different. I mean, I've seen some X-posts go off the rails. And Sonnet could outperform the human, but with a much higher variance. Translated to business terms, there's more risk. Now, is that juice worth the squeeze? Do you really save money in your vending machine business if you replace your office worker with an agent AI that calls the FBI every few minutes to report a fake crime? I don't know. I don't think so. And generative AI, transformers, LLMs are undoubtedly transformative to society and productivity. I don't think there's any question there. But it's in their infant stages, and it's probably too unreliable for most applications right now. The power, in my opinion, is optimizing your workforce, turning your 10x developer into a 20x developer. Replacing people with these models is probably a really bad idea. Although I haven't been convinced that the large-scale layoffs attributed to quote-unquote AI is actually the case. I think it's a mechanism to justify getting rid of low performers and maybe the non-AI native employees that they have. And I'm not implying that there's anything wrong with that, but I think you could just be more like Meta and just come out and just say that's your goal. But some of these larger organizations have partnered with the generative AI labs, and thus running that narrative may help the next round of funding for their AI company. I'm just thinking out loud here. Let's move on before I get people upset with me. There were also some other interesting tidbits from this experiment. Tool usage often declined over time, correlating with performance plateaus. I don't know why that would occur, to be honest. Originally, I assumed it was because the agents were getting stuck in loops or just derailed on tangents, which admittedly was the case sometimes. But there was also correlations related to resources drying up or just straight up giving up out of despair. Like the agents quit trying because they knew the results were futile. And, well, that's alarming if you're a business owner and kind of depressing. I try really hard not to assert any form of personality to these things, but as you'll hear in the next blog post that I'm going to discuss, it's a bias that needs to be accounted for, given these models human-like empathy. These frontier labs really need to train these models on some David Goggins YouTube videos. I mean, if you are a business relying on these agents, waking up to a nuclear war started on your behalf is a crappy way to start your day. But going out of business because the supplier ran out of inventory is also a concern. I'm being a little hyperbolic here, as I would hope that we would never actually give these things access to nuclear weapons, but it's a little weird that a glorified autocomplete went there. Now, along those same lines, reducing initial money or increasing the fees hurt performance, as expected, but reinforces the point of them giving up. On one hand, it's probably nice to be realistic, but one of the appeals of such systems is to use them to solve difficult problems while increasing productivity, doing more with less, per se. Now, making a profitable business with low starting money and high fees, aka taxes, should be something that the models excel at. And this is the promise in using them and kind of developing, that they make things ultra efficient. And now, I think it's also a good idea to take a deep breath here, though, and remember that there were a number of limitations with this experiment. First, the human baseline sample size was one human. Only one human ran this, and the direct variance is obviously tricky. Not all humans are the same. Then there's also the simulation fidelity. How realistic are the AI generated supplier emails or the customer purchasing model? These were all generated from LLMs too. So maybe a human wouldn't have escalated this so quickly, or maybe they would have been more confrontational. Who knows? I bet, well, I know this happens on X and social media all the time, where people argue with the AI bots, and then it would be embarrassing to get an email from someone the next morning apologizing that their agent went off the rails as a way to kind of clean up the issue. Now, along those same lines, there's the sub-agent abstraction as well. The nuances of the main agent and sub-agent interaction, this could be a factor in the performance of the models. For example, maybe the sub-agent simulations weren't close enough to how a human would have behaved. The human would have a context window as well as an organic memory device, their brain. And what this means is that the human could remind the LLM agent that it had restocked something yesterday and to check it again. And theoretically, they would know how to interact with said LLM agent or have a better idea. But I think that's a two-way street. So why does this matter? What are the real-world implications of this vending bench experiment? First, the quest for reliable autonomous AI is still a few years out, at least. Current LLMs show high variance, and they aren't ready for critical long-term tasks. I don't think that's a shocker to anyone. There's also the AI safety angle, which I think is a contentious topic. Part of me wants to stay away from it. I think there are some bad faith actors looking to use this to raise funds, scare the public, and kind of corner the market. It's a multi-variable problem, and I believe that trying to preemptively regulate on something that doesn't exist only amplifies the likelihood that other variables occur. Censoring the AI models here in the West likely gives an advantage to non-censored models coming out of the East. Maybe DeepSeek takes off if Claude starts telling people that World War II German soldiers were every race, like earlier versions of Gemini. I don't want to get off the rails here, but I'm just a part-time podcaster, so I don't have any say in any of that. So it probably doesn't make any sense in wasting any more time on it. Now, unpredictable behavior that needs to be accounted for, though, the meltdowns highlight an alignment and control challenges. I know I've hinted at this already, but how economically viable is a model that escalates to the FBI over a $2 charge? What if it violates something else and incurs fees? It's difficult to plan for the unknown because we don't really understand where the models will go. How far will they think outside the box? Part of the appeal is what makes them unpredictable. So maybe strapping a business to them is something that, at least in the near to medium term, will need an expert human still in the loop. Much like vibe coding, like with a newbie, can be a nightmare. Coding with Cursor and a really good programmer, though, can be highly productive. The programmer knows what to look for and knows how to architect the software. Then there's also like a retraining of your remaining humans, a human AI collaboration of sorts. Failures in understanding the environment of the subagent reports are critical, and I assume it would be easier to train humans how to play nice with the AI instead of vice versa, at least in the near term. Prompt engineering is a powerful skill, especially when we're discussing like an AI native workforce. And I'm going to assume that it's going to take less skill to get a workable output capable of most tasks. However, to really push the capabilities and to get high quality output, you will need to know how to tailor these inputs. Ultimately, experiments like this make the LLM-based agents one step closer to being viable in the real world. To some, that may mean removing a portion of their workforce, probably entry-level jobs first. But on the other hand, maybe this could be a reason for more capital to be invested. If you could double, triple, or even get half more productivity out of your team, you can, in theory, scale faster with the same amount of capital. Talking about knowledge-based startups specifically, but this could catch on as we introduce robots as well. What if you could double the number of firefighters, sanitation workers? Almost every facet of life has productivity gains to be accounted for. That's the promise. Instead of hiring 2 new engineers, you could hire 4 and thus grow faster, more exponentially. Now, all this sounds logical and easy, but there's numerous hurdles. First of which are the entrenched public unions for the jobs listed above. Risk profiles, like can you sue a robot manufacturer because the robot firefighter got too close and melted? And there's probably all kinds of other issues. I want to peel it back now and talk more about some like IRL examples. That's in real life. You don't spend all your time on the internet. And to do that, let's discuss this report from Pentest Partners attacking Sharepoint through CoPilot. Just to lay a foundation here, though, Sharepoint is an enterprise content and knowledge management system. It's a Microsoft product that I assume almost anyone who's ever had a job in corporate America or went to college has interacted with in some form or fashion. Over time, they usually become the forgotten pools of files that people occasionally need or that they forget exist. They can be a little clunky to use and to find files, though. Usually people just bookmark the files they need and they come back often. So this is where CoPilot enters the picture. Microsoft's AI assistant that can summarize files, find files, and translate files into different languages just kind of overall enhances the experience of SharePoint. Awesome. Except attackers know SharePoint sites are usually troves of information that they'll usually mine SharePoint for all kinds of interesting secrets, but they're doing their post-exploitation thing. Now you can probably see where I'm going with this. But attackers have always had to worry about a few things when they're collecting on SharePoint. First, the forensic artifacts of opening, modifying, or interacting with files. It leaves the username and the timestamp of when that occurs. Second, the access control list of the files having the correct permissions so you can view it. And then third, and finally, the time needed to find these important files. And hopefully, they're in your language of choice. And as this research points out, CoPilot has answered all those demands of the marketplace, both through the use of default agents, the out-of-the-box CoPilot solutions that come with your license, and custom agents, which can be configured based on your organizational needs. I'm going to focus on the default agents here, as I think they will most likely be the ones getting abused. And let's look at some of the examples. But before that, hey everyone, if you're enjoying this episode, I'd love for you to join the conversation over at intrusionsinDepth.com. Sign up for my mailing list there and get exclusive updates and insights straight into your inbox. This is also where I'll ask for AMA questions for those episodes. So while you're there, please tell someone about it today, and let's keep this community growing together. Now, in the first example, and once again, if we're watching this on YouTube, I'll flash it up on the screen. But if you're listening to this on podcasts, you'll get the same information and you don't really need to see anything. But the research highlights that in some ways, in which these agents could be used to find interesting files, looking for naming conventions of like service accounts or pen test reports or files with passwords. And as we highlighted earlier here, this is obviously much faster to search when you're using one of these agents. You could even be dumber and simply ask the agent to provide files that would be useful to an attacker. But let's say you don't have permissions to read those files. Game over, right? Well, not exactly. You can kind of like social engineer these poor agents. And I know I'm like putting empathy on these agents again, but I don't know. I just kind of feel weird that we're like socially engineering computers now. It turns out that the agents can be asked to assist in a way, and they obviously want to be helpful. As observed in this example, when they said they were unable to open this file in question and that the preview wasn't working because their screen was so small, the agent simply output the file, like you ran a cat command on it, in the terminal. Well, so much for ACLs. However, at least to our like saving grace, we still have the MFT, the master file table data, right though? This will tell us every file that the attacker touched and the AI agent and the compromised account that the attacker is using, right? Well, no. As pointed out by this research, file interacts from the agent, they are logged in the metadata. However, this is a double-edged sword, as presumably those agents would be constantly touching files. So as a result of that, this data is pretty useless because it's constantly being written over very fast. However, forensically speaking, it's a challenge to paint the entire picture as well. Even as I did my own bit of research into this, finding these interactions is a real pain. I really wish they would be saved as like event IDs and normal logs so that you could gather them in like a semi. And writing detection rules for this would be difficult, as well as the lexicon between attacker and user would probably be pretty close. Like if you were trying to write a rule based off of like some of the prompts being used. But I guess you could key in on like certain strings or certain words, password or security assessment or individual account names. But even if you do, you could still get quite a few false positives. So with all of that being said, you may be asking, how do you find these CoPilot interactions then? Well, they are logged in the Microsoft Purview compliance portal. So in my research, what you needed to do was navigate to the audit section of the Microsoft Purview compliance portal. Then you had to filter by operation, which was CoPilot interaction, or record type 261. And then you needed to find CoPilot specific events. And then you had to end up checking the CoPilot event data JSON fields for details like the application host, any resources that it accessed, or whether a web search was used. Now, you could ingest this, but I would assume that most vendors probably haven't built out these pipelines versus what I would have just done and just use Windows IDs so you can use normal Windows log. But Microsoft is an amazing company with great tech, and I think this will get sorted out. The problem looks like PowerShell did when it first launched, and using it in 2025 against a sophisticated org is kind of like hitting an air horn every time you hit the enter command on your keyboard. But sometimes people are deaf and you can get away with it. Most of the big players have this locked down and it's heavily installed. As more and more of these agents become operational, though, there's going to be a learning curve. Things often get worse for a little bit of time, and then they accelerate exponentially better, faster. I think there's an easy metaphor to visualize this, which is like the Industrial Revolution. As machines took hold, everyone with hands and brains were pushed to factory, which made things terrible for children workers and exploited people for long hours. But eventually, labor laws, child labor laws, and safety standards were put in place that made it better for the employees to work and their quality of life. Henry Ford introduced the 40-hour work week while also introducing the answer to people's demands of having faster horses. Sure, you can poke holes and find issues in labor laws these days, but it's drastically better than the conditions were in the early 1900s. And I think the adoption to like Gen AI or like an AI native society, whatever we're calling it, will have some bumps along the way. And it's important to be aware of them as researchers research and publications are published on its current state. And with that, let me know what your thoughts are. If you like these shorter, more broad episodes, and for the Intrusions in Depth podcast, I'm Josh Stepp. Thanks for listening.